friends, welcome back to Techno Education Academy. In this video lecture, we will discuss YouTube Differential Manometer. In previous lecture, we will discuss a simple manometer. In this video lecture, we will discuss differential manometer. First of all, what is the application of manometer? As we know that manometer is used to measure the pressure, and differential manometers are the devices used for measuring the difference of pressure between 2 points in a pipe or in two different pipes. Here you can see that this manometer device, it is connected with two pipes, or we can say it will measure the difference of pressure between 2 points in a pipeline. A differential manometer consists of U-tube containing a heavy liquid whose two ends are connected to the points whose difference of pressure is to be measured. Generally, for heavy liquid, we use mercury. Now we will discuss different types of differential manometer. The first one is U-tube differential manometer, and second one is inverted U-tube differential manometer. Here we will discuss two cases for U-tube differential manometer. The first case is two pipes at different level. Here you can see that the elevation of the pipe is different. The second case is two pipes, or we can say A and B, at the same level. Here you can see that the manometer device is connected with the pipes, and the level of the pipe is same. And here you can see that two pipes at different elevation or at different level. The first case is two pipes at different level. For that, we consider H. It is the difference of mercury level in the U-tube. Here you can see that this is a H. What is H? Difference of mercury level in the U-tube. This is U-tube. Here you can see that, okay, here we are considering X. It is the datum line or reference line. So from the datum line, here you can see that H is difference of mercury level in U-tube. Y is distance of the center of point B from the mercury level in the right limb. This is the right limb and this is left limb. So here you can see that Y is, it is the distance of the center of point B from the mercury level in the right limb. Same as what is X? It is the distance of center of A from the mercury level in the right limb of U-tube manometer. Rho1 is density of liquid at A. Okay, whatever the fluid it is filled in this in left limb, whatever the fluid it is filled in left limb of U-tube, its density is Rho1, density of liquid at A. Rho2, it is the density of liquid at point B. Rho-G, it is the density of heavy liquid, or we can say mercury. Okay, it is highlighted with dark pink color. Here you can see that it is highlighted with dark color. Taking datum line at XX. Okay, this is the reference line or datum line. Pressure above XX in the left limb. Okay, this is a left limb. Okay, this is a left limb and this is a right limb. So as we know that pressure, it will depend on rho, density of the fluid, G, gravitational acceleration, and H, it is the height, or we can say liquid column in the manometer. Okay, we have already proved that P equal to rho GH in our lecture series of fluid mechanics, hydrostatic law. Okay, if you want to clear your fundamental, okay, how can we prove that P equal to rho GH? Then you can visit our playlist and watch this video. Okay, so according to the fundamental, P equal to rho GH. Okay, so the pressure due to liquid column, okay, H plus X, as we know that P equal to rho GH. So at point A, the pressure is due to the liquid column. So at point A, pressure is due to the liquid column of height H plus X. So P equal to rho gh. So here we are considering density is rho 1, g is the gravitational acceleration, its value is 9.81, plus height is h plus x from the reference line xx to the point A, plus PA. What is PA? It is the pressure at point A. Same as the pressure in the right limb of the U-tube manometer. So here you can see that there are two liquids. Okay, the first one is heavy liquid. It is filled up to height h, and other liquid density rho 2, light liquid. Its liquid column is y. So at point B, the pressure due to the liquid column of mercury, it is rho g h. Rho g, density of heavy liquid, g 9.81, it is the gravitational acceleration, and h, it is the height column of mercury. So pressure due to the height column of heavy liquid is rho g h, plus pressure due to the height column of light liquid. Okay, so light liquid height is y, and its density is rho 2. So plus rho 2 g y, plus pressure at point B is Pb, where Pb is the pressure at point B. We have already derived these two equations in previous slide. Pressure in the right limb, pressure in the right limb, and pressure in the left limb. Now we will compare equating the two pressure. Okay, here we have already considered reference line or datum line. Now we will compare two pressure. Okay, so rho 1 g h plus x plus Pa. Okay, it is the pressure in the left limb, equal to rho g h plus rho 2 gy plus Pb. It is the pressure in the right limb. Okay, here we compare the two pressure, because here we are considering the datum line or reference line. So this Pa term is positive and Pb term is also positive. So whenever it is shifted from right hand side to left hand side, so it will become negative. So whenever we make the object Pa minus Pb, so this term it is shifted right hand side, so it will become negative. So minus rho 1 g, so minus rho 1 g in bracket h plus x. So it is the simplified form by shifting the Pb term from right hand side to left hand side, and this term from left hand side to right hand side. So Pa minus Pb equal to rho g h plus rho 2 gy minus rho 1 g h plus x. Now we will simplify the equation. Okay, here you can see that, okay, this term is separately multiplied with this term and this term. Okay, so h into g. So further we simplified this equation. So here you can see that here the h g term is common in this term and this term. Okay, so it is keep it outside. So equal to h into g, rho g minus rho 1 plus rho 2 gy minus rho 1 g x. So it is the difference of pressure at A and B equal to h into g in bracket rho g minus rho 1 plus rho 2 g y minus rho 1 g x. So by using this equation, you can measure the difference of pressure for A and B whenever the elevation difference is there, or we can say level of the pipe is at different level. The second case for differential manometer, we are considering if A and B at the same level. So 2 points A and B are at the same level and contains the same liquid of density. So pressure above xx in the right limb. Okay, here we are considering datum line, but our case is the elevation difference is not there. But in this case, we are considering A and B at the same level. Pressure above xx in the right limb equal to pressure due to the height column of mercury. Here we are considering density of mercury is rho g, or we can say heavy liquid density. G is 9.81 and height of mercury is h, plus pressure due to the height column of light liquid. Here we are considering density is rho 1, for example. Here we are considering rho 1. So rho 1 Gx plus Pb. And pressure above Xx in left limb. Okay, for left limb we are considering the same liquid. Okay, here we have already considered the 2 points A and B are the same level and contains the same liquid of density. Here we are considering density rho 1 and here we are also considering density rho 1. In previous case we are considering rho 1 and rho 2. Okay, in this case we are considering same liquid in both the pipe. Okay, for same level. So pressure above Xx in left limb equal to, here you can see that the height is h plus x from the point A, from the datum line Xx. So due to the height column of h plus x, the pressure at point A for the light liquid equal to rho 1 G h plus x plus Pa is the pressure at point A. Now we will compare the pressure, equating the two pressure. We are getting rho G into G into H. Rho G means density of heavy liquid. This G is gravitational acceleration. H is the height of mercury. Plus rho 1 Gx plus Pb equal to rho 1 G H plus x plus Pa. Further we simplified the equation and we are getting Pa minus Pb equal to rho into Gh plus rho 1 Gx minus rho 1 G H plus x. But here we are considering the same liquid, rho 1 in left hand side and rho 1 in right hand side. Okay, and the elevation and the level is also same. So further we simplified this equation. So this rho 1 Gx and rho 1 Gx term is cancelled because this is plus term, and whenever it is separate, or we can say rho 1 G, it is multiplied with h plus x. So we are getting minus rho 1 Gx. So it is cancelled out. So the remaining term is Pa minus Pb equal to Gh in bracket rho suffix G minus rho 1. So this is the equation of pressure when the two pipes are at same level, whenever we are measuring the pressure. Now we will discuss inverted U-tube differential manometer. It consists of an inverted U-tube containing a light liquid. Okay, this is an inverted U-tube and it will contain the light liquid and its specific gravity is S. The two ends of the tubes are connected to the points whose difference of pressure is to be measured. It is used for measuring difference of low pressure. What is the application of inverted U-tube differential manometer? It is used for measuring difference of low pressures. Let the pressure at A is more than the pressure at B. Here we assume that, here we consider that the pressure at A is more than the pressure at B. So here you can see that the level of the mercury, okay, in A side, due to high pressure, okay, it is shifted upward, and due to low pressure in B as compared to A, it is shifted downward. Let H1, it is the height of the liquid in the left limb below the datum line XX. Okay, here we are considering datum line or reference line, and H1, it is the height of liquid in the left limb below the datum line XX from point A. H2, it is the height of liquid in the right limb. H, it is the difference of light liquid. Here we are considering light liquid. Okay, its specific gravity is S. And H, it is the difference of light liquid. Okay, from the datum line. Rho 1, density of liquid at A. Rho 2, density of liquid at point B. Rho S, density of light liquid. Here we are considering light liquid in inverted U-tube differential manometer. Rho S, density of light liquid. Pa, pressure at point A and pressure at point B, Pb. Taking Xx as the datum line, then the pressure in the left limb below Xx. Okay, here you can see that for the left limb, okay, here we are considering Pa, it is the pressure at point A. Here we are considering minus sign because it is inverted U-tube manometer, and this line, it is below the reference line or below the datum line. So we are considering negative sign. Okay, and according to the fundamental of hydrostatic law, P equal to rho g h. So due to the height column of liquid H1, the pressure is rho 1 g H1. Same as pressure in the light limb below XX or datum line. So PB minus, we are considering minus again because it is below the datum line. So minus pressure due to the height, or we can say liquid column H, is, here we are considering rho 2. Okay, density of liquid rho 2 g H2. We are considering rho suffix H. Here we are considering rho suffix S. It is the density of light liquid, and here the column is H. So due to the light liquid column H, the pressure is P equal to rho g H. So rho suffix S, it is the density of light liquid. G, gravitational acceleration, its value is 9.81, and height is H. Now we will compare or equating the two pressure. This equation and this equation we will compare, and further we simplified this equation. So PA minus rho 1 g H1 equal to PB minus rho 2 g H2 minus rho suffix S, density of light liquid, into G into H. Further we simplified this equation and we are getting PA minus PB equal to rho 1 g H1 minus rho 2 g H2 minus rho suffix S into GH. This is the equation of pressure difference PA minus PB for inverted U-tube manometer. By using this equation, you can solve the example of inverted U-tube manometer. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also share with your friends.